Going off of trigonomic ratios, since we're working with right triangles, we will have some triangles with square roots as one of the sides. So we have to know how to fix an irrational denominator. All of these are examples of irrational denominators. They have square root boxes on the bottom. So we have to fix that before we can do our trigonomic ratios. So I'm gonna do like a just like a little recap on how to rationalize the denominator first, and then attach it to trigonomic ratios and finding those. So first thing, we take the bottom and we try to break it down. 1 and 17 just has 1 times 17. Nothing is repeating here, so we cannot break down the square root of 17. So this one is easy. All we're gonna do is take the square root of 17, and what we're doing is we're multiplying it times itself. So we're gonna do this, square root of 17 times square root of 17. What that does is on the bottom it squares the 17, which is going to give us a square root of 17. So the bottom becomes just 17 because it cancels the boxes, it multiplies times itself, and then it squares itself. So for example, I'll write this one out so that you have this. So the square root of 17 times the square root of 17 is 289. And then if we take the perfect square of 289, we know it's 17 because we literally just multiplied 17 times itself. So the bottom will always become that very number that's inside the square root box. And then, so let's bring this over. So for the top, we have 5 times the square root of 17. Those two just attach because they can't multiply. And then we're going to keep the top, and then we square rooted the bottom as 17. So this is our rationalized fraction. We cannot cancel 5 with 17 on the outside, so that's gonna stay as is. There will be some that we can do that part for, which you'll see as we go through. So that is the way to rationalize. The short way, now that I explained basically all the steps, that, you know, the reasons why, I usually just, after I explain the reasons why, I give a little shortcut, because again, our bottom will always be whatever's inside of this square root box. So if we just bring this up, this is 5 times the square root of 17, and then take the 17 out, and then that's our answer. So that's all we're gonna do. One, we cannot break down the inside. For the second one, we will have an extra step because we can break it down. So this one's done. That's gonna be our rationalized denominator. For this one, 68 can be broken down. We can do, we're gonna have 6 at the top. We can do the square root of 6 times the square root of 8. 8 times 6 is 48. I can break down 6 to the square root of 3 times the square root of 2. I'm going to cancel my 6 since I broke it down. 8 can be broken down to the square root of 4 times the square root of 2. And then the 4 can be broken down to square root of 2 times square root of 2. So the trick for this is taking out what's repeating. So I have 2 2's, and then I have another 2 2's, so 2 sets of 2's. So we have 6 at the top. On the bottom we have 2 2's, so we're going to put a 2 for those, for each set. So there's a group of 2, so these first 2 are being represented by this 2. So that's 2, and then these second set will be represented by a second 2. So 2 times 2, because the number inside the box is 2. But we have a leftover 3 here that does not have a second square root of 3. So we cannot take out the square root of 3. So this is something that you should have learned maybe when you did Pythagorean theorem. It's the same exact thing. We're still working with Pythagorean theorem. We're just putting it into trigonometry. So this altogether equals 6, 4 square root of 3. So that's the first part. That's the broken down part of 48. Now we have to rationalize the denominator. So I'm going to scoot this down here. So now to rationalize our denominator, we have 6, 4, 3. So I said earlier that we can just bring the square root part up. For the 17, it was just the up here, we brought the 17 up. We're not gonna bring up the 4. The 4 is not part of our square root. So we have 6 with the square root of 3 now. And then the rule was to take out the 3. And then we have times 4 next to it, which is this outside number that's gonna stay there. So we have 6 times the square root of 3 over 4 times 3 is 12. And then last step now that we didn't have with the very first one, 6 and 12 are on the outside. They can be reduced together. 6 and 12 can be reduced with 6. So if I do 6 divided by 6, that gives me 1. Keep your square root of 3. 12 divided by 6 is 2. So this is our final answer, our final rationalized answer. We could have brought up the 48 first and done the breaking down step at the top. And then we would have done this part first, basically. And then the breaking down part after. So you can do that. You can do like I did for the very first one, bring this up and then break it down at the top. So I think I'll do that. I'll do that one as well. So if you need a second to write down this part, pause the video and copy it down. I'm going to erase it and I'm going to do it the other way so you can see both ways. So go ahead and pause the video to get this information down. So I'm going to do it the way that I did the very first one. Well, not the first one. I didn't bring it up first. Well, I did. Actually, I did. But we didn't have to break down the 17. So let's say instead of breaking down the 48 at the bottom, we bring it up first, like I had first said. So we'll have 6 square root of 48. So now there's nothing left at the bottom. Or no, sorry, we have 48 at the bottom, actually. So we brought the 48, square root 48 up, and then we brought the 48 out. So right here, I can already break down 6 and 48. 6 and 48 share a 6. If I do 6 times 6, or 6 divided by 6, sorry, that's 1 square root of 48 over 8. And then now I can break down my 48, which we did earlier. That gave us, it was 2 times 2, that was 4, and we had a leftover square root of 3 on the inside. So I'll do that one more time. So we did square root of 6, square root of 8, square root of 3 times 2 to replace the 6, square root of 4 times 2 for the 8, and then for the 4, we have square root of 2 times square root of 2. So we had 1, 2, 1, 2. So 2 groups of 2s and 3 on the inside. So we had 1 square root. We're going to have times 4 on the outside now because those 2 2s come out as 2 times 2. Square root of 3 all over 8. So we have 2 times 2, that's 4 square root of 3 over 8. And then we can reduce 4 and 8 one more time, making it 1 square root of 3 over 2. And that's the final broken down number. Okay, so for the next one, let's do this one first. Okay, so again, there's 2 ways to do it. We can break down the inside first if it can be. If not, then we just skip to moving it. In this case, 3 cannot be broken down, so we're going to bring up that square root. So we have 8 square root of 3. Remember that at the bottom we have a 5 already. that's already there, 5. And then we're going to take out the 3 and multiply it times 3. So we have 8 square root of 3 over 8, or 5 times 3 is 15. This one's simple, that's it, because 8 and 15 do not break down. They don't share anything, so I can't do anything there. 3 and 15 do share something, but since 3 is inside of the box, I cannot simplify 3 with 15 because 3 has the square root box. So that's it. That's as far as that one goes. So we brought up the square root inside the box, took out the 3 at the bottom, and multiplied it with the 5 that was already at the bottom. So that one's done. The next one, we can bring it up or break it down first. I think I'm gonna bring it up first, and I'll do the other way. So let's bring up the 12. So we have 4 times the square root of 12 over, we have a 7 already at the bottom, and then we're going to bring out the 12 to multiply it with. So we have 4 square root of 12 over 7 times 12 is 84. So we can reduce 4 and 84 first with 4. 4 divided by 4 is 1. Oops. And then 84 divided by 4 would be 21. So all we have to do now, even though the 12 is at the top, the number 12 inside the parenthesis, the square root box can be broken down. So our denominator is already rationalized. It's 21. It's already done. But we do want to break down the 12 inside that inside the square root box. So if we do square root of 4 times square root of 3, and then square root of 2 times 2 for 4, we have 2 2's that can come out. So at the top now we have 2. We're going to keep the square root of 3 because it does not have a second 3 to take it out. This one, we're multiplying it technically by the 2. 2 times 1 is 2. Whenever you have a 1 on the outside, you can just eliminate it since 1 doesn't change your answer. And then we have over 21. So that is our final broken down answer. I'm going to do it the other way now as well, when we break down the bottom first and then bring it up. So again, if you need a second, just pause the video to write this way down, but I'm going to do the second way as well. So if we would have broken down the bottom first, we would have had square root of 4 times square root of 3, 2 times 2 for the 4, cancel the 4 because we broke it down. So here we have those 2 2's that come out, but those will multiply with the 7 that's already there, and then the 3 that's left over by itself will be on the inside. So at the top we have 4. 2 times 7, we're doing 2 times 7 again because that group of 2's becomes just 1 2. So 2 times 7 is 14. And then we keep the square root of 3 at the bottom. Here we can reduce 4 and 14 with 2. That gives us 2 over 7 times the square root of 3. And now we rationalize our denominator. So we have 2, 7, square root of 3. We're going to bring up the 3, square root of 3. So 2 times the square root of 3. 7 is already at the bottom. And we're going to bring out the 3. So 2 square root of 3 over 21, which is what we had when we did the first form of this, which is when we brought up the rational first. So it gives you the same answer whether or not you break down the irrational denominator first, or if you bring it up first, it gives you the same answer. So now that we have that recap, we can use this now to do our ratios.